Hello, everyone, and welcome back to Black Harbor's Advanced Tara series. Going to let Justin kick us off today. Justin.
Howdy, welcome back everybody. So again, today we will be talking about TARAs, of course, and specifically the security requirements. So we've gone over some of the kind of conceptualized portions of these requirements in terms of the goals, but now we're going to get down to the kind of nitty-gritty of the actual requirements themselves. So what is a requirement in engineering, right? So this is going to be something where we have very specific language that kind of drills down what exactly we want without saying the exact, like, this is what we need, right? So what this says is, as an example here, we have a requirement that says the component or this feature or uh, ECU, whatever it might be, right? In this case, it is shall transport people from A to B. It shall support at least 4 passengers. So if we look at the list of kind of things that might be applicable to this, so in this case, it's kind of a transportation vehicle, right? So if something can transport somebody from A to B, almost all of these are able to do that, right? But then shall support at least 4 passengers. A bicycle, nope. Motorcycle, nope. But the rest of these seem like they probably still could. The passenger must be able to travel in any weather condition at a consistent speed. So consistent speed and even the weather condition here would kind of knock out the sailboat from this case. And then journey must not depend on air or water channels. That would further eliminate sailboat, but also the passenger airplane. So now pretty much the whole top here is out, as water channels is also going to be that motorboat now. And then the cost of travel must be less than 25 cents per mile. And lastly, must not be must not emit carbon byproducts during normal operations. So the cost of travel for the less per mile is going to kind of eliminate this passenger airplane again, while we do also have the air also not being allowed, right? So for the gas car here, we have the cost of travel might be a little high in terms of fuel, but we also want to not have carbon byproducts. So a electric vehicle is going to be pretty much our only options here, or a hybrid fuel cell electric vehicle would kind of be the best fit for this, right? That's going to be what matches most accurately to the requirement. And again, we're not saying within the requirement that you need to do X, Y, and Z. We're saying that it shall do these things or shall not do these things, if that makes sense. So what exactly are these requirements again, right? So a security requirement is a statement of required security functionality that will ensure security properties and objectives of a feature or component is being satisfied. These statements aim to solve or eliminate a specific vulnerability. So in our world of kind of cybersecurity and TARAs and all of that, right? So we'll complete those TARAs and then we'll come up with the kind of attacks that might be possible to have some damage scenario play out. And then we say, okay, let's make sure that those attacks aren't possible, or at least are way too difficult to make sense for anybody to try and do, right? So to kind of get to that step then of, okay, let's actually tell people how to protect against these, we need to now create these requirements that will eliminate or solve those specific vulnerabilities. So again, here's kind of the steps you would take while doing a Tara, and it is kind of the last steps here of some companies may not even want this level of detail. They might be doing this stuff kind of on their own, but always helpful to kind of give pointers. But you're going to be kind of deriving those requirements for specific functions and assurance levels to mitigate the risks and evaluate the design and implementation for compliance within the requirements. So that last step is going to be kind of the testing phase. So the requirements are going to be written. You want them, as with the goals that we had covered before, you would like them to be testable so that once the requirement is written and attempted to be adhered to, you can verify that adherence is actually done and there is no part of it that doesn't follow as it should, right? So if you have something in the requirement that says CPU must be able to run at, let's say, like 2 gigahertz or something like that, if you want to go back then and check that, you would have to, of course, take the CPU and make sure that it's actually able to run at that speed. So things like that are things that you want within the requirement, but needs to be testable, right? So you can't say something vague like uh, CPU must be fast or something. You may want something that does say that a CPU is able to perhaps handle like 100 messages within 20 seconds or something like that, to where you're giving the criteria around what has to be kind of done without saying how fast exactly the CPU needs to be. So that kind of gets us to the objectives here. So we're trying to maintain the intended operational performance of all vehicle functions. We want to ensure the safety of the vehicle occupants and other road users. So this means that we want to protect anything in the vehicle that might cause damage, not just to oneself, but also one's surroundings. And of course, that also then would mean that we want to protect the privacy of the vehicle occupants, intellectual property of the vehicle manufacturers, and their suppliers. So this means that anybody who's got their contacts on their like uploaded via Bluetooth, perhaps to their vehicle, we don't want somebody to be able to grab that. We don't want any login information or credit card information to be able to be taken. And then, of course, also the vehicle manufacturer and their suppliers. So this is going to be, of course, physical components have their own designs, but so does software, and so does the hardware that runs that software, right? All of that is kind of lock and key and behind NDAs and all sorts of kind of protections there. So we want to make sure that we keep all of that as locked down as possible. So no privilege escalation, no ability to read code or modify it or anything like that. And then, of course, kind of along the lines of the credit card, like I had mentioned, we want to prevent fraudulent transactions, private or commercial. And of course, theft of the vehicle is not a good time. So we want our requirements to uh, have this outcome of not allowing any of these things to happen or maintaining function, right? So we want to protect, but we also don't want to subtract from functionality. That's going to be one of the kind of main things in security in general, which I'm sure you're all aware of, is that as you try and up security, functionality oftentimes will decrease in terms of if you try to add encryption on something, it's going to take longer for it to be received, decrypted, and understood. And again, sent out, you have to encrypt it first and then send it out. So things kind of start slowing down a little bit, starts taking more processing power. And then in terms of like the physical aspect, even if you're talking about functionality less, but cost perhaps, if you're looking at the physical, like a key, right, getting into a vehicle, perhaps the key cylinder doesn't have as many like anti-lock picking or other security features there that would be cheaper. But if you have different locking pins or false gates, and then also perhaps adding in some electric security into that, where you're checking that the key has the correct RFID chip or something like that, then you're able to, of course, kind of add security to it, but comes with cost. And perhaps the key is bigger and somebody doesn't want that, right? So kind of a give and take, something you want to work with uh, through all of security pretty much, and vehicles, of course, are going to be no different. So now we kind of look at what exactly would we be writing these requirements for, right? So this is going to be kind of down to the asset types. So we might be writing a requirement for a type of log that a ECU has. Perhaps it has a SQL database, and we want to tell it that no SQL injection is possible, right? So we would want to have that within a requirement and then test that by sending bad injection type messages to it to try and store and see kind of what happens, right? So that's kind of just going to be one of these examples. But we want to see also what state the data is in and kind of how an attack might be performed. So whether it's going to be at rest, in motion, or in use, this also comes down to what attacks are kind of possible, right? So for credentials, this might be something to where we don't want somebody to be able to kind of do that privilege escalation and reading of files that they should not have access to. Of course, we also don't want passwords to be saved in like clear text, right? But it's kind of just an example there. And it does go for logs, which normally are not actually encrypted. Should be, could be, but aren't always. So that might be something to where they could just read that, and we would want that not to happen. So we would want to write requirements talking about different protections we kind of want in place and things we want to not have possible. And then, of course, that also shows us, or now we get to kind of the where that data and this attack might happen. And then that also gives us an understanding of what requirements might be needed. So for the, if we go back here and look at the packets, right, these are in motion, but they're also going to be kind of running through this whole layer stack of TCP/IP. So if we have these packets being sent to the back end, perhaps for a maybe somebody's updating a feature of their vehicle and it requires some sign-in or something, right? So that's both credentials, but also packets. So we'd have the application that'd be taking their input. We would have the protocol working with that data. We would then also have the physical component that is actually doing the math and whatnot, right? And then we have the network that's actually going to be sending and receiving that. So the packet is kind of through all of this, but largely it's going to be the network that we're looking at in terms of once the packet leaves the vehicle, not just once it's formed or when it's being formed or the inputs to it, but the actual network is going to be what we want to look at. So there we would want to write some requirements stating that before it even gets on the network, we want it to have X, Y, and Z protections in place to ensure that it has kind of safety within the network itself. And of course, we would like to have the network itself be vetted, but that is kind of difficult to do as we can't own every single ISP out there, right? So kind of same images we had before with the security goals and concepts, but now looking specifically at the requirements portion of it. So requirements need to be motivated by the goals which justify them on the higher level. So again, we need to look at the why, what, and where, the property, assets, and layers, and then see where it fits to protect those different functions, that different, the privacy, all of that, and be able to align those through to the goal of perhaps keeping functionality or protecting privacy, right? Then all of those will align up to some greater concept. So an example here would be the storage and transmission of data should be secure and should be controlled. Normally this would be saying shall. The vehicle shall be designed to be resilient to cyber attacks. The vehicle shall be designed with the capability to detect cyber attacks and respond appropriately. So these are, of course, just examples of the goals. So the requirements would then go kind of deeper into that and say, instead of just the storage and transmission, we would get into perhaps the storage itself, say what level of encryption it should have, say like AES 256 or better or something like that. And then when we say that a vehicle shall be designed to be resilient to cyber attacks, instead of just saying that, perhaps we will say that a specific spoofing of a message isn't possible due to X, Y, and Z protection, which is done via this methodology, right? So the security requirements are going to be getting a lot more kind of in depth here. And that is going to be it for the security requirements. Thank you everybody for stopping by and listening. Hope you learned something and I look forward to talking to you again soon.
Thanks again, Justin. Appreciate everyone tuning in. See you all soon.